Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, we're covering the cardiac cycle and the electrical conduction system. This is how the heart beats in a coordinated and efficient way. Let's go over it step by step. So in diastole, ventricular filling is passive. Blood moves to the ventricles from the atria based solely on ventricular relaxation, which is also known as ventricular diastole. After this, we have atrial systole. Here, the atria contract, and this raises atrial pressure and forces a little more blood in the ventricles. This additional volume of blood is called the atrial kick, and it accounts for about 5 to 30% of the cardiac output. Now, atrial systole happens as a result of an action potential from the SA node. The SA node stands for the sinoatrial node. And this is the first part of the conduction system and is the heart's pacemaker. It's a clump of cells in the wall of the right atrium, and it initiates an action potential triggering atrial systole. Now, it's in the right atrium, but it causes both atria to contract. It's important to know that the cardiac muscle has myogenic activity. This means that it can contract even without any neurological input. It can do so as the sinoatrial node generates 60 to 100 signals per minute, which leads to 60 to 100 beats per minute. Now, even though neurological input is not required to generate the contraction, it is very much required in speeding up and slowing down the rate of contraction. But that's something we'll talk about in a future episode. Now, after this, the signal reaches the AV node. The AV node is the atrioventricular node, and it is between, as the name suggests, the atria and ventricles. The AV node delays the signal, and it does this to allow the ventricles to completely fill up before contraction. Once the ventricles are filled up, then the signal travels down the bundle of His and its branches, and these branches are embedded in the interventricular septum, which is the wall between the ventricles, and go to the Purkinje fibers. What the Purkinje fibers do is they distribute the electrical signal throughout the ventricular muscle, starting at the apex is the tip, moving upwards. The muscle cells are connected by intercalated discs, and these discs contain gap junctions which directly connect to the cytoplasm of adjacent cells and allow for ventricular systole. Ventricular systole is the coordinated ventricular contraction. During this, the bicuspid and tricuspid, also known as the atrioventricular valves, close. They do so to prevent backflow, but doing so also produces the lub sound. The lub sound is the first sound in the heartbeat, which is known as lub-dub. And after this, blood is ejected into the pulmonary artery and aorta as the semilunar valves open. Ventricular diastole begins after the blood is pumped out. Here, the ventricles relax, your semilunar valves close, which creates the second sound, the dub sound, and blood begins to refill the atria. That is your cardiac cycle. And a quick mnemonic to remember the electrical conduction system, which is the sinoatrial node, the AV node, the bundle of His and Purkinje fibers, can be remembered as stab a big pig. Now, let's just move on to controlling heart rate. So if you are in rest and digest, your heart rate will be slow. Rest and digest means the parasympathetic system. And what the parasympathetic system does is it uses the vagus nerve to slow down the heart rate. To speed it up, the sympathetic system uses adrenergic signaling and uses norepinephrine and epinephrine. You may have also seen people who have artificial pacemakers, and this happens if your sinoatrial node fails. Well, if your sinoatrial node fails, first, your AV node will take over, but this will be at a slower rate, and this may be acceptable for some people, as the rate is 40 to 60 beats per minute. But if they both fail, Then your Purkinje fibers will step in to act as a pacemaker, but only at 20 to 40 beats per minute, and this is usually insufficient, and that's why patients need artificial pacemakers. So a quick recap, you have systole, which is your contraction phase. Here, blood is pushed out of the heart, your AV valves are closed, and your semilunar valves are open. You have diastole, which is the relaxation phase. Here, your chambers fill with blood, your AV valves are open, and your semilunar valves are closed. Electrical activity starts in the sinoatrial node and goes to the AV node, and then to the bundle of His, and then to your Purkinje fibers. The system is automatic, but it is highly regulated, which is critical for delivering blood efficiently. That's it for today. Next time we'll go deeper into the cardiac cycle and how to read an EKG.